Okay, so we're going to talk about absolute value inequalities. We're going to do a few absolute value equations also. Remember that the definition of absolute value is the unit distance from 0. And first we're going to consider the absolute value of x equals 3. The absolute value of x equals 3 is equal to 3 at 2 points, negative 3 and 3. In between negative 3 and 3, we would say the distance is less than 3, and over here, distance is greater than 3, and over here, distance is greater than 3. So in between negative 3 and 3, the distance is less than 3. If x is greater than 3, the distance is greater than 3. And if x is less than 3, the distance is less than 3. So from here, we could say negative 3 less than x if we're talking about the interval that does not include negative 3 and 3. So let me write that down real quick. Okay, now if we were to talk about this interval, notice that the statement is the same. The distance is greater than 3, which means that the absolute value is greater than 3. So absolute value is greater than 3. And that means that if the absolute value of x is greater than 3, we could say let me just scratch that out. That should say x is less than negative 3. Scratch out this mistake here. Or x is greater than 3. Now, on a number line, if the absolute value of x is less than a, then that means negative a is less than x is less than a. We would sketch the number line like this. So only in between negative a and a. And in interval notation, we would have negative a to a. And that would be the solution set for this absolute value inequality. If we have absolute value of x is greater than a, then we can say that x is less than negative a, or x is greater than a. This is an important equivalent statement to understand from the previous page of notes that if the absolute value of x is greater than a, that statement says x is less than negative a, or x is greater than a. And we really should write it like this, because that will help us with not only solving, but properly writing the interval notation without getting the number line backwards or things jumbled around. So from here, we can draw the number line. I do parentheses and brackets on the number line so the viewer can more easily tell the difference between set inclusion and not. So if you have an open dot right here at negative a and an open dot right here at a. And then this helps me see the interval notation a little easier. And that is the symbol for set union, which we knew we were going to end up with set union from that word or right there. So union translates to or in English. All of these say the exact same thing. Our goal in this section is to be able to go from the absolute value inequality, write it as an inequality without absolute value. So here, we want to be able to write it as an inequality without absolute value, so that way we can solve the inequality, and then once we have the inequality solved, we can graph on a number line and give the solution in interval notation. So right here, if we go back and look at the less than, here's where we would have the inequality without the absolute value. Then we can take that, draw the number line, and solution in interval notation. Of course, this is going to work exactly the same if we have a less than or equal to. In that case, the three-part inequality would have less than or equal to and less than or equal to. The number line would have inclusive brackets. The interval notation would have inclusive brackets. And the same thing goes if you have greater than or equal to. You would change everywhere you see a non-inclusive statement, you would change it to an inclusive statement. So there's no reason to rewrite both of those. The only thing that would change is the inclusion. Okay, let's take an equation first, real quick. Let's do the absolute value of 5 minus 3x equals 12. Let's solve this absolute value equation. So remember, whatever this quantity inside the absolute value is, that has you want to think of it as a distance of 12. So we can rewrite that as 5 minus 3x equals negative 12. And we also have 5 minus 3x equals 12. And over here, we end up with x equals 17 over 3 after subtracting 5 and dividing by negative 3. And here, we end up with 7 over 3. Or now, this is a finite solution set, so we don't need to use set union. We would just use, the set builder notation since we just have a finite. So remember, set builder notation is just a list of elements, so this doesn't necessarily have to be in order. 7/3 is less than 17 over 3, but remember, in set builder notation for finite set, you're listing elements, whereas in interval notation, you are writing an interval as it lies on the number line. Okay, let's take a look at some linear absolute value inequalities. So let's solve 6 plus 4x less than or equal to 8. Now this statement, the absolute value inequality should be rewritten as a 3-part inequality. And I subtract 6 from all 4 parts, then I'm going to divide by 4. And we get this inequality statement. Negative 7 halves is less than or equal to x, which is less than or equal to 1/2. We can write that, plot that on a number line. And this solution has square brackets in interval notation. Okay, let's take a look at 3x plus 1 greater than or equal to, let's just do 0. Actually, let me change that to a 10. We'll cover the 0 and negative numbers here in a second. Okay, this absolute value inequality splits up into 2 statements. 3x plus 1 less than or equal to negative 10, or 3x plus 1 is greater than or equal to 10. Remember, this part of the statement covers the negative side of the number line, the distance that is farther away than 10 units on the negative side of the number line, and this side causes, this side takes care of the positive side of the number line. One of the most common mistakes is to just get rid of that absolute value, and that's not a true statement. If you just are just looking at the positive side, that violates the definition of absolute value. So we need to remember that we're 10 units of distance farther away on the left side, which would be translate to less than or equal to negative 10. So if I subtract 1 over here, negative 11, x is less than or equal to negative 11 thirds. And if I subtract 1, I'll have 3x is greater than or equal to 9 on this side. So x is greater than or equal to 3. So here is our solved inequality, and we want to put this on the number line. So less than or equal to negative 11 thirds, greater than or equal to 3, shade, and then the solution in interval notation is parentheses negative infinity, negative 11 over 3, bracket, union, bracket, 3 to infinity. Okay, I jumped the gun just a few minutes ago, and I said 3x plus 1 greater than or equal to 0. Let's solve that logically. And we can just cite the definition of absolute value. Any unit distance is greater than or equal to 0, and all that's saying is distance is non-negative. So if x is a real number, this statement is going to be true. Absolute value of 3 times any real number plus 1 is always going to be greater than or equal to 0 no matter what real number you choose for x. So let's take a look at another one that's kind of fun. So let's do x plus 8 less than -4. Okay, so we want an x value plus 8, run that through absolute value, we want that to be less than -4. So again, the definition of absolute value, unit distance is, absolute value is non-negative. So from that, we can say for all real numbers x, absolute value of x plus 8 less than -4 cannot be true. And then we can quite simply say no solution exists. And that's also the same as saying the solution is the empty set.